Alright guys, let's do 10.4. Let's start with the warm-up. Put me on pause please and do the problem, then hit resume. So try this by yourself first. It says given the universal set 1, 2, 3, 4, 5, 6, 7, and 8, we have a subset 2, 3, 5, and 6 because they're all within here. It says set B is a subset of set U, which is universal. What is the complement? They're using the word complement. They could have used the symbol of complement of B. That would have been either not B, or the other symbol would be B with the little asterisk up here. So either on the EOC or on the test they could use either one of these symbols or actually spell out the word complement. Complement means what is not in B. So if you go to B, 2, 3, 5, 6, 2, 3, 5, and 6, what is not in B would be the 1, the 4, the 7, and the 8. So choice 3 is the correct answer. Alright, let's jump right into 10.4, solving radical equations. You guys have been dealing with radicals in chapter 10. The difference now is that it's going to be within an equation. The biggest trick to this is isolate the radical. Right off the bat and get it by itself. Make sure you leave the answer in simplest radical form before you circle any of it. So let's look at the first example. It's an equation and it has a radical in it. The radical is not by itself, so let's isolate it by doing the inverse of subtracting 5, which would be to add 5. That gives us the square root of x is equal to 3. Now, in order to get rid of a square root, we do the inverse, and the inverse of squaring or square rooting would be to square it. These guys cancel each other, but you have to do it to all terms. So we're coming up with an answer of 9. I don't want to circle that answer until I actually check to see if it works, because there is a possibility it's an extraneous root, which means that all of our math is right, but the actual answer does not check back in the original problem. It won't happen that often in Algebra 1. It will happen 50-50 and 50% of the time in Algebra 2. Square root of 9 is 3. 3 minus 5 is -2, and -2 equals -2, which works. So 9 is a root or an answer of the problem. What about when you have a radical on both sides? Then you're actually you can't isolate it, because if you brought one over you'd end up with a plus or minus. If you end up with a situation like this, that's an equal sign by the way, then all you're going to do is square root both sides, or square both sides. This is not right. So let me get a different color. You're going to square this side, and you're going to square this side. That square root will cancel that, and that square root will cancel that. You're left with 7x minus 4 is equal to 5x plus 10. We're solving for x. Let's go ahead and subtract, get my x's together. It gives me 2x minus 4 equals 10. Add 4 to both sides. That's going to give me 2x is equal to 14. Divide by 2. We're coming up with x equals 7. Let's go ahead and make sure we check it before we do confirmation. Square root of 7 times 7 minus 4. Does that equal square root of 5 times 7 plus 10? 7 times 7 is 49. 5 times 7 is 35. 49 minus 4 is square root of 45. And square root of 35 plus 10 is square root of 45. I could simplify this, because 9 times 5 would be 45, and 9 is a perfect square. But really it's no need to, because your left side and right side came out the same, you're good at that for your check. You don't have to go any further. If you want to, that's fine too. Alright, let's try this one. Be careful. Obviously there's a possibility of an extraneous root. N is equal to the square root of n plus 12. We have the radical by itself. Let's do the inverse of square rooting, which would be square. That means I've got to do it to both terms. So this is going to cancel. I'm going to be left with n squared is equal to n plus 12. Notice that's a quadratic equation, which means you've got to get it set equal to 0. And either factor if it's factorable or use the quadratic formula. N squared minus n minus 12 equals 0. Let's see if this is factorable. Remember, the quadratic formula always works, so if you ever get frustrated on a test, you can always go quadratic. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. Because I picked different signs, I have to be able to subtract off to get to my middle term of 1. That's the 3 and the 4. Put the larger number next to the middle term sign. If you forget that, then guess and check. And that rule only works when your leading coefficient is 1, by the way. Set each equal to 0. We're coming up with two possible roots. We're coming up with a -3, and we're also coming up with a +4. Let's check to see if either one of these work. If none of them work, it's no solution. Maybe one will work or maybe both will work. So I'm going to put it back into the original problem. Let's try -3 is equal to square root of -3 plus 12. -3 plus 12 is 9. And the square root of 9 is plus or minus 3, but when you check, you're going to take the principal root, which is the positive. So this one does not work. Okay, so that's a little bit tricky. Check number 2, let's put in 4. We get 4 plus 12. 4 plus 12 is 16. When you take the square root of 16, because it's in the equation, you're going to take the positive, the principal root, which would be the positive square root of 16, which would be 4, and that one checks. So there is an extraneous root. It's the -3. So be careful. When you have a square root, I know the square root of 9 is plus and minus 3, but when you're doing it in a check within an equation, you take the principal square root, which is the positive one, and ignore the negative one. Okay, you're going to try this one by yourself, so make sure you put me on pause, go through it, and then see how you did by putting resume. Okay, we've got to get the square root by itself, so that's square root of 3y is equal to 2 minus -8, which is -6. The inverse of square rooting would be to square. That gives me, these guys cancel, we get 3y is equal to -6 squared, which is equal to 36. Divide by 3. We're coming out with 12. Is that right? I don't know. I need to check. 3 times 12, 8 out here. 3 times 12 is 15. Oh, I'm sorry, 36. I'm adding that. Plus 8 equals 2. Square root of 36 is 6. Plus 8 equals 2. 6 plus 8 is 14. And does 14 equal 2? And the answer is no. So this is an extraneous root. Therefore, the final answer is no solution. So you guys got to be careful for those extraneous roots. And that takes care of Chapter 10, Section 4.